Let's delve into how we democratize Xcode projects at scale. At that time, actually, we find out a tool named Tuist. First of all, I would like to mention about the problems with the Xcode projects. We face three key challenges with Xcode projects. Those are the complex project setup, inconsistent build configurations, and frequent conflicts with Xcode project files. And also, I would like to give an example. We noticed that due to the manually setting build configurations, we left some modules optimization levels as none, and it led to the increasing in application size. Tuist simplified our project setup process by eliminating manual tasks and make it easier module setup with Tuist scaffold command. Also saved us from conflict happening in Xcode project files. Additionally, we take advantage of Tuist graph and plugin features to enhance DevX to top. So once we migrated to Tuist, we figured out that our hundreds of modules were linked dynamically. So, Beyza, would you like to give us a comparison of static versus dynamic libraries and tell why we choose the static linking over dynamic?
Of course, but Hello everyone, I'm Beyza. I'm working as an iOS developer for about 4 years, and for the past 2 years I have been working in the Trendyol iOS platform team. In this team we are developing more technical components and improving our DevOps process to make them more efficient. Batu, would you like to continue?
Of course, Beyza. Hello, I'm Batuhan SAKA. It's been 4 years since joined Trendyol. For the past 2.5 years, I have been working at iOS platform team with a focus on modularization and observability topics.
Okay. Now, today we will talk about the incredible change in build speed at Trendyol, but first let's provide some details about the application. The picture in the slide, as you can see, Trendyol is a super application containing 5 different channels, and these channels are developed by approximately 80 plus developers and QA engineers. These people are divided into 10 sub-teams, and each release during cycle, these teams coordinate their RC flows and make them their bug fixes. After all tests are done, we are sending the new app version to the App Store. And this process repeated approximately every 2 weeks. Okay, now we can continue. Of course, the project doesn't look like this. At the beginning in 1980, Trendyol is just a simple application for the Turkey in an e-commerce environment. And those days we had no idea about the super application challenge. Maybe Objective-C could be the trick for us. But nowadays, as you can see, we support the same feature in 3 different app targets. Okay, now Batu, would you like to give some details about the modularization journey at Trendyol?
Of course. In this timeline, you can see what kind of steps that we have passed during this transition. And each dot represents the sections that we will talk about in that presentation, and we will focus each of them. So, Beyza, would you like to tell more about our first modularization attempts?
Of course. Okay. Now we can start to talk about the entire process, and the first step is the modularization attempt. Trendyol started the modularization attempt in 2019, and those days this application was not being developed as a super application. Although we wanted to separate our frameworks as domain frameworks, which containing more business features, and the kit frameworks, which containing more technical components to create standard designs across all the projects. Also, we handled all the third-party libraries with using pod5. Okay. And those days, Trendyol acquired a second-hand marketplace which named Dolap, and after that, we wanted to add Dolap Lite version in those apps. That's why our team wanted to try something new, and we create all the submodules in the separate repository. When we send the new app to App Store, we handled all the management with using version tag IDs. Now we can talk about what was our problem in this process. Okay, when the start time, our teams was just the 15 developers, and after the years, our developer numbers are getting increased. Because of that, time to time, we have to manage some conflicts. It happened in the version tag IDs. And also, if we wanted to use anything from the Trendyol main app targets in the different repository, we could not handle of this problem. That's why to fix these issues, we added the all submodules to main targets, and we sent the all modules with the same project. Okay. Now we can continue. And I need to check. Okay, now it's time to talk about the dependency and modularization dependent management process. Okay, but would you like to give some insights about the SPM POC?
Of course. As we use the Xcode projects to manage our modules, there were lots of challenges. First of all, we can focus the problems that we face while using the SPM. Actually, we transformed all of our modules to SPM, but faced with the resolution issues in Swift Package Manager's internals, and as we have lots of dependency with those modules, it was just, you know, getting stuck, and we were not able to build the app. And another issue was that most of the third-party dependencies had no SPM compatibility, so we decided to discontinue the use of SPM.
Okay, but we could not solve our problems with using SPM. But how did we manage all these problems? Could you explain?
Of course. So let's delve into how we democratize Xcode projects at scale. In this time, at that time, actually, we find out a tool named Tuist. And first of all, I would like to mention about the problems with the Xcode projects. We face three key challenges with Xcode projects. Those are the complex project setup, inconsistent build configurations, and frequent conflicts with Xcode project files. And also, I would like to give an example. We noticed that due to the manually setting build configurations, we left some modules optimization levels as none, and it led to the increasing in application size. At that time, so let's take a look at what Tuist handled for us. Tuist simplified our project setup process by eliminating manual tasks and make it easier module setup with Tuist scaffold command. Also saved us from conflict happening in Xcode project files. Additionally, we take advantage of Tuist graph and plugin features to enhance DevX to top. So once we migrated to Tuist, we figured out that our hundreds of modules were linked dynamically. So Beyza, would you like to give us a comparison of static versus dynamic libraries and tell why we choose the static linking over dynamic?
Of course, but at those times we used the dynamic libraries to add all modules in our project. But when we analyzed our project, we discovered some problems when we used the dynamic libraries. And you can see some of features in the slide. The first one is Apple recommends maximum 5 dynamic libraries in our project, but nowadays we have already 170 modules, and that's why we have to choose static libraries to eliminate this problem. And on the other hand, as you can see, dynamic linking is happening at the launch time. On the other hand, static linking is at the compile time. Okay, actually with these differences, we can eliminate our remain time less than 1 second, and it's a huge differences for us, especially, you know, our customers don't want to wait in a splash screen more than 2 seconds. Okay, And the other hand, application size changing because of that. In that time, our application size more than 100, and when we change all the modules, transform everything to the static libraries, we realize that our application size decreased. However, static libraries has some disadvantages for us. The most important two things are bundle matching and managing resource. We have to handle all of these manually, but thanks to Tuist, we handle these with using Tuist templates easily for all the modules. Okay, now we can continue to talk about the third-party dependency management. But before that, we need to understand what is XC frameworks. Okay, basically, XC frameworks give us the pre-compiled version of the libraries. And especially if you are using the pod files or any external libraries, you don't want it to recompile everything over and over again, especially after a clean build. And thanks to XC framework, we can handle this. If you wanted to add any third-party libraries, XC framework, no need to compile this XC framework in your project again. And the other beauty is that we can handle the indexing problems easily after the clean build time. Okay, the slide, as you can see, at those times, our total build time at almost 600 seconds. And we analyzed that this build time, we discovered that the pod files is just half as time of the total build time. Then after that, we change all the pod files to the XC frameworks, and then we analyze all process again, and we realize that the build time is nearly 300 seconds. Okay. As a result, we converted all the third-party dependencies into XC framework until now on. And now we can continue to talk about the last subject is, just a second, I'll talk that. Okay, we made third-party dependency build faster. But how could we improve build times in our internal modules, Batu? Would you give an insight for us?
Of course, Beyza. We are using interface modules for internal modules. Let's dive into the details. But first, I would like to remind you to how Xcode build system works. The Xcode build system compiles the modules interdependencies first to prevent issues like the unresolved symbols during linking. So I'll share some insights about what could go wrong with incremental building. The growing module interdependencies may disrupt the incremental build and causing the recompilations. Another issue, if the feature modules were mutually adding each other as a dependencies, that may lead to circular dependency issues over time. Let's demonstrate this. If you make any change on the favorite handler kit, that will cause on the recompilation on the yellow modules and the Trendyol main app target. And that will increase your build time. With the interface modules approach, we are able to eliminate all these problems. Every module you see here, search module and discovery module, will have two targets. One of is concrete, the another is interface targets. As you see in the diagram, only Trendyol main app takes them as a dependency, and if search module and discovery module should access each other, they should take their interface targets as dependencies. As long as you stick into the interface and make changes on the concrete targets, it will not cause the recompilation on the other modules. And take advantage of the mentioned benefits right here. And also, let's take a look at an example graph. It's quite complicated that we extracted with the Tuist. As you see, I'm not sure that you see, discovery module will bring lots of dependencies, and especially most significant ones are the ID common kit and favorite handler kit. They are directly using their concrete targets. If we remove the ID common kit and access favorite handler kit through its interface target, our graph would look much cleaner and straightforward. as you see, once you extract the favorite handler kit into the toTarget and use through its interface, you eliminate all of this mess. As we split favorite handler kit into the two targets, any change made to the favorite handler kit's concrete target, it will only recompile itself and main Trendyol app target, not the other dependent stuff, because it's used by its interface target, not the concrete one. So I assume that many of you ask that how you can access these modules since you don't rely on concrete targets. The answer is dependency injection container. Let's take a look at an example of DI container usage over this approach. Actually, our concrete target, in this case, basket module, will have a factory class that will provide necessary implementations that will be accessed through another modules. So as you see, there is a function called create basket module, and it provides a UI view controller instance as a result. So, and it should be defined in the concrete target, basket module. As we will import the modules interface targets across another concrete modules, we should define their public APIs in their source interface targets. In this case, basket module interface, and there is the interface should be marked as a protocol, a public protocol, and then so we are ready to define the registrations of concrete and interface APIs to our DI container, and then we will be able to retrieve the concrete values over the public APIs. As a result, we registered modules in the main app target and ensured that we will be able to access the across the runtime in any module. However, it would be great to keep in mind, if you miss to register any modules, your app might crash when you attempt to access the modules in runtime. At the other hand, Beyza, would you like to tell us that how we can empower the build efficiency with remote case?
Okay, but if you remembered, we talked about how we add precompiled libraries in our project to eliminate the build time. And what if we could do something like same thing as our internal modules in locally? Especially in Tuist remote cache give this access for us. With this, we can add the hashed module in our targets in our project. But before that, let's give some details about the problem. Okay. We both know that every module is recompiled on each developer's machine over and over time again, and I said that we have more than 80 developers, and that's why it's a huge time messing. To fix this problem, we tried to discover something new, and then we find that Tuist remote cache. Okay. In a basically, Tuist hash the module and cache them, then upload to the remote server. And other developers easily access this cached version and download in your local. Then in this diagram, I take it from the Tuist documentation. As you can see, if we wanted to upload any module with caching, we just write this command line tool. And after that, if any developers download in your local, it just basically write the Tuist focus cache command, and then they will get the cache module. Okay. And then I explain over again. Other developers can use cache the same hash modules. And in the next slide, we will see the result, maybe. No.
No, not that.
Okay. No, I just, okay. Sorry, now we can continue.
Yeah. The next topic is the core platform libraries. The core components used by all domain teams is separated to another package. But let's take a look to the problems that led us to this decision. Actually, the foundational structures such as extensions over Swift, primitive types, environment, logging, and the another stuffs separated into the another package, because the teams might change them over time and it was not trackable enough. So to ensure consistency across the project, we consolidated essential functionalities into the another Swift package manager package, and directly linking through the version management. Yeah. So Beyza, what if our domain team members want to build the app, but only changing their own modules? How they will be able to run the only affected modules and see the change easily? Because, you know, it brings lots of burden, and if you are just working for the middle domain, you should not recompile the Trendyol's main app. How can we solve that?
Okay, but for this question, actually we have two different solutions, and the first one is that we call channel app. In 2020, we defined this structure because we have a lot of channel teams, and they are most of the time just develop the specific modules, and they don't want it to build the other modules that don't change anything over and over building time again. And the next slide is we will show the problem. As you can see, we have two different developers, and the first one is just only working in meal application, and the second one only working instant delivery. Okay. Now, if we, in the past, if we wanted to get some application in our simulator, we had to build all entire application to run. With these channel apps, we eliminate this problem, and we get only channel application if we want to for any channels. And now we can solve the build times. Okay. As you can see, the first one are the main target app build timing, and the other ones are the channel applications build target total time. As we can see, there are huge differences, and with this we gain a lot of time for each developer. Okay. And in this slide you can see how look like channel app in the simulator. Actually, it really looks like the main app target, because we add all the same features, but they build really faster. As a result, after the discovered this channel application, we gave this opportunity to every channel teams, and now they are using this channel application in your development mode. Okay. And also we have some other teams that don't have any channels, because Trendyol application has some sub-teams. They divided into different groups like account basket or PDP. They don't have exact channels. Because of that, they had to run the entire application to get any build in your simulator. Okay. To fix this, we create some other structure which we call preview app. With this feature, we just add some specific modules, what if we want, and then we combine between them. After that, we can run only these modules in our simulator. Now we can see the problem, okay, and after that we can see the solution. As a result, and the last one is we can see the one example in our simulator. Would you like to continue, Batu?
Yeah, for sure.
Okay.
Let's demonstrate it.
This is really same as the channel application, but we have some other features to easily integrate their developers mode. Okay. Now you can see we have some basic structure to add other developers teams features, and with this also we eliminate the build times really slower. And the last one, what's next? Actually, until now we talk about what we are doing in the past. From now on, we will talk about what are we going in the future. And the four things are our main challenge right now. The first one is Tuist Cloud. Why we need it? Because, as I mentioned before, we wanted to catch everything, and then we wanted to use in every developer's local machine. And with Tuist Cloud, we can handle it easily. And the other one is macros. You know probably macros. Right now we have a lot of mocks in our application because we have to write every functions in our presenter, and we have to mock most of class. With macros, we hope that we eliminate this mock class structure. And the third one is page speed score. You can realize that we have a lot of page in our application, but we have no data for about what was the page speed in 2 months ago and what the changes can happen in those times. Maybe we can handle with this page speed score, and also we are going to develop our application and add new features to make more modularized. Thank you.
Thank you so much.